video. I hope you know already what is rational number. Rational number can be written as in the form of p by q, but where p and q will be integer and q will be not equal to 0. If I will ask you why q will equal to not 0, then you will say that it will be not defined. When I will ask you why it will be not defined, then you will say that its value will be infinite. It means its value will be goes to infinity. When you will put 0 in denominator, then its value will be infinite. So it will be not defined. But if I will ask you why it will be not defined, then you will lag over here. After that, if I will ask you why rational number can be written as in the form of p by q, then obviously, of course, you will lag over here. Today, I will briefly teach you about rational number, why it can be written as in the form of p by q, where p and q will be integer and q will equal to not 0. Actually, decimal representation of rational number will be if it is terminating, otherwise if it is not terminating, then it must be recurring. This recurring means it will be regularly recurring. We can also say that it will be regularly. We will take all types of number over here. Just like this one number is integer and whole number also. Second one number we will take, this is natural number, integer, and also this one is a whole number. Third one number I will take, this one is a integer number, and other one number like that 3 upon 2 and 1 upon 3 and other number root 2. Have you taken all type of number over here? Yes or no? This one is an integer, or you can say whole number and natural number. This is natural number, whole number and integer. This one is only integer. This one is fraction number, and this one is also fraction number. This one is also in the form of square root of 2. Other type of number we can take just like that 3.14 and other number just like that 3.24 and 4 to the 8. We have taken all types of number here. Yes or no? We have taken all types of number over here. We will write all types of number in the form of p by q. If we can write it as in the form of p by q, then that number can be said as rational number. Now we are writing it just 0. We can write it as in the form of 1 into 1, then we will get 1 upon 1. Yes or no? It will be not chance. Yes or no? Second one number, that is 1, can we write it as 1 into 2 upon 2, that is 2 upon 2. Yes or no? Minus 1 also can be written as minus 1 into 3 upon 3, that is minus 3 upon 3. Can we write? Yes or no? We can write. And other types of number, that is 3 upon 2. Can we write it as 0.58? It is already written in the form of p by q, where p and q all are integer. Here p and q all are integer. 1 is also integer and 1 is also integer. 2 is integer and 2 is also integer. 3 is integer and also its denominator already in integer form. And all the denominator are not equal to 0. I will say that why it will be not equal to 0. This 1 upon 1, what does it mean? What does it mean? It says that 1 in 1 parts. 2 upon 2 it means 2 in 2 parts. 3 upon 3 it means 3 in 3 parts. Here 3 upon 2 it is already written in the form of p by q. It means 3 in 2 parts. What does it mean? We will get 1.5. get 1.53. This one number 1 upon 3, if we will divide, what does it mean? It means 1 in 3 parts. Here denominator is already not equal to 0. Then we will get this value equal to 0.3 to be reckoning. It means 3 will come after decimal places up to infinite terms. This one can't be divided completely by 3, and we will get this type of value. And this 3 goes to infinite terms, it will be not completely defined. If we will find root 2, then this value will be 1.41, and this type of number, it will be also go to infinity, but it will be also goes to infinity. What does it mean? It means this value is not terminating. Terminate means just like that. We will take the example of train. Then this train is going from Patna to Prayagraj. After Prayagraj, this train is just terminates. It means train isn't going after that. Terminate means value stops after decimal point. Value stops after decimal point. Just like that we will see in the decimal point definition. Value stops after decimal point. Here, just look over here. This value just stops after one decimal point. Yes or no? Yes. But this value doesn't stop after decimal point. This value doesn't stop after decimal point. But it is repeating up to infinite times. It is value doesn't stop. Value doesn't stop over here. Doesn't stop. But it is repeating. It's repeating up to infinite times. It is not completely divisible by denominator. This type of numbers can be said as non-terminating, but it must be a recurring number or repeating number. If we will find this type of number just like that, root 2, root 3, root 5, root 6, and also root 7, and also root 9, root 10, root 11, then this type of number, its decimal presentation will be non-terminating and non-recurring, also non-repeating number. So we can't write this number in the form of PYQ, but this type of number can be written in the form of PYQ. This is already written in the form of PYQ. If you want to write it as in the form of PYQ, then it is easy because this is terminating decimal. Then we can write it as instead of decimal in the denominator. We can put 1 over here, and after decimal there is just a single digit, so we can put 1 0 over here. Then this decimal will be removed over here. So this can be written as 15 upon 10. So 3 upon 2 equal to 15 upon 10. These are same fraction, same value, and there is a this will be cancelled by 5 and 3 are 15 and 5 to the 10. So this will be 3 upon 10. So this decimal place, that is terminating decimal, we can write it as in the form of PYQ, where P and Q all are integer. Here 3 is integer and 2 also integer. But this denominator is not equal to 0. This 3 upon 2 says us this 3 can be divided into equal parts, and we will get 1.5. But if we will divide 1 upon 3, then we will get this one number. To write this one number, there is a shortcut method for this one, and there is a long method I will explain later. This is this syllabus, and if you want to write it in the form of PYQ, then it is easy to write. There is a total number we will write over here, and we will subtract all the numbers which is not terminating over here, not repeating over here, that is only 0 over here. And instead of repeating number, regularly repeating number, we can write 9 in denominator. We will write 9 in denominator. So we will get 3 minus 0. We will get 3 over here, and 9 we will get. So this can be cancelled by 3 1 3 and 3 3 9. So this will be 1 upon 3. Here 1 is also integer and 3 is also integer. It follows the property. It can be also written in the form of divided. And here denominator and numerator all are integer, but denominator is not equal to 0. What does it mean? It means that 1 divided in 3 equal parts. But this this is terminating, and this type of number is non-terminating, but this is regularly repeating over here. But this type of number is non-terminating and non-repeating, so we can't write it as in the form of PYQ. Last one is 3.14. This is terminating decimal because of after 2 decimal points after digits. After decimal, 2 decimal points after decimal value stops up over here, then this is terminating decimal. It is easy to write the terminating decimal in the form of PYQ. Yes or no? Instead of decimal, we will put 1 in denominator. After decimal, there is a 2 digits over here, so we will put 2 zeros over here. Then this decimal will be removed. So this can be written as 1314 upon 100. Yes or no? It is divisible by 2, so we can write 250 upon 100 and 2 15 are 30 and 2 7 are this one 157 upon 50. Yes or no? Yes or no? If we will divide here, numerator and denominator all are in integer form. Yes or no? Here 50 is also not equal to 0. Yes or no? This fraction 157 upon 50. What does it mean? It means that 157 is just divided in 50 equal parts. Yes or no? Last one number, that is 3.24 to the reckoning. What does it mean here? 3.224. 4 comes regularly in infinite times. Yes or no? Can we write it as in the form of PYQ? It is easy to write. We will write all the numbers over here, that is 3 to 4. That is 3 to 4. We will write all the number without making and without decimal. 314. And we will subtract the number which is not terminating over here. That is 32. We will write without decimal. And instead of recurring number, we will put 9 in denominator, and after decimal there is a single digit, that is 2, which is not recurring. Instead of this one, we will put 0 in denominator. So we will get 314 minus 32. We will get 4 minus 2, 2, and this one will be 11 minus 3, that is 8, and this will be 2 upon 90. There is a common factor in 82 upon 90. If there is a common factor in them, then we will make it co-prime. Co-prime means there is a no common factor between numerator and denominator. Then this will be easy for verification when we will divide numerator by denominator. Then you can make it co-prime just like that. It will be divisible by 2. Then this will be 45, and this will be 2 on the 2, 2 on the 8, and 2 on the 2. That is 141 upon 45. This will be easy. So when we will divide 141 upon 45, 141 upon 45. If you want to verify it, then you can just verify it. You have to just divide by 141 upon 45. You will get this one number where decimal permutation of this number will be non-repeating and but regularly repeating. It will be non-terminating value. Doesn't stop after decimal point, but because of it goes to infinity. But it will be regularly repeating because of there is a 4 which is just regularly repeating over here. So we can write it as in the form of PYQ. So we will get, we can say the number which has decimal permutation will be terminating. It means value stops after decimal point. Otherwise, the value is this decimal permutation will be non-terminating, but it will be recurring. It means value doesn't stop after decimal point. Just like over here, just like this one number and this one number also, value doesn't stop. But after decimal point, the digits, there is some special digits which is regularly repeating over here. These type of number can be written as in the form of PYQ. So we can say that the whole number in these are, and the decimal permutation of that number is terminating, and if it is not terminating, then this is regularly repeating. It all types of these number can be written as in the form of PYQ. So it will be rational number. And this number which is this root 2, root 3, root 4, root 5, and which has the decimal permutation, it will be not terminating, it means value doesn't stop after decimal point, and it is also not repeating, where value doesn't repeat after decimal point. So we can't write in the form of p by q. Here, value of root 2 we have found, I think, 3.14 digits after decimal point. But it is now up to yet we can't be written as in the form of p by q. So this number is irrational number, and this number is rational. This is also rational. This is also rational. This one is also rational. Because of this number can be written as in the form of p by q. So you can say that this is the complete definition of rational number. If decimal permutation of rational number will be terminating, then it will be also written in the form of p by q. And if it is not terminating but regularly repeating, its number can be also written in the form of p by q, where numerator and denominator are in the form of integer, and denominator will be not equal to 0.